Directing effect. Directing effect. Whose directing effect? Directing effect of a group already present on benzene. Now to understand this, let's start from very basic. Now to understand this effect and what this effect is and what are the consequences of this effect, what are the implications of this effect, we can understand those things only if we understand few things like, suppose I'm asking you to draw the resonating structure of phenol. Now don't worry about why I'm asking this, but just draw the resonating structure of phenol. Now if you have forgotten, let me brush you up quickly how to draw the resonating structure. For drawing resonating structure, we start from the electron rich site. This oxygen is having lone pair, this is electron rich site. What we do is we empty up the orbital adjacent to electron rich site, so that the electron can start moving from electron rich site to electron deficient site. So what we do is we put the electronic density of this bond into the orbital of this carbon, so that this carbon, which is adjacent to oxygen, becomes empty. And when it becomes empty, the electron of this oxygen will go to the orbital of this carbon. So there will be a bond formation between oxygen and carbon, but then there will be a plus charge on oxygen because oxygen is giving its electron, but it is not electron deficient. So this is a stable oxygen, and you will have a negative charge here. From this, without drawing further resonating structures, I can tell you, or you can see yourself, that electronic density has been pumped into the benzene ring. Now the pumping has been done from oxygen. Oxygen has pumped its electron into the benzene ring because benzene ring previously was neutral. Now benzene ring is having charge. So now the ring is negatively charged. Without resonance, the effect of resonance, it was napped. After the effect of resonance, the benzene ring is having a negative charge, and this negative charge of course will be shared by different atoms by the virtue of resonance. But the bottom line is the ring is possessing a charge. That means the ring is not neutral. Now the ring is having negative charge. That means electron have been pumped. That means the lone pair of this oxygen has been pumped into the ring. So this pumping effect is called electron giving effect, and this is the mesomeric effect of OH group on the benzene ring. Of course, we will have more resonating structures. This negative charge will further go to different atom. Now to proceed with drawing the RS, what we do is we bring a plus charge with minus charge, because plus minus forms a bond. So to bring a plus charge here, we need to develop a minus charge here. So we bring the electronic density from the bond into the orbital of this carbon. So you start from the bond and you end up at the atom, signifying the electron of the bond has been put into the orbital of this atom. Okay, so you get a bond here, you get a bond here. This bond is as it is, and this negative charge will be here. Again you will get one more resonating structure. This negative charge again will go to ortho, carrying out the same procedure. Now at last, what you do is you again bring a plus charge here. So to bring a plus charge here, you need to break a bond, and the bond I can cite here. So you give the electron to this oxygen, so this carbon is devoid of its electron, developing a plus charge on this carbon, and this plus and minus will create a bond here. So the next RS will be like this. Oxygen was having plus charge. After getting electron, it will become neutral. So this is the final resonating structure. You start from here, you end up here. Now the thing is, if you draw the hybrid, for drawing the hybrid, what you do is you draw the basic skeleton first. Now in case if you are not very handy with resonance, I will suggest you go back to the lecture in which we have studied resonance, and you come back listening to this lecture, because it will be a pain in your back if you don't understand these things further. I'm trying my best to make you understand, but in case still you are having a problem, then go and listen to the lecture of resonance before proceeding ahead. Now if you have to draw the hybrid, now to draw the hybrid, you draw the basic skeleton first, without the charge, without the double bond. You draw all the atoms, you draw all the single bond. Now what you do is you look at the position of double bond. Let me look at this side. You have a single bond here, double bond here, double bond here, double bond here, single bond here. That means at here you don't have a single bond, you don't have a double bond. You have a mixture of single bond and double bond. That means you have a double bond character here. Similarly, if you look at this position, you have a double bond, you have a single bond, single bond, single bond, single bond. That means here you don't have a single bond or a double bond, you have a mixture of these two. Now what percentage of double bond is there, we don't worry about it. It's somewhere between a single bond and double bond, that is good enough for us. So this is, here you have a double bond character. Similarly, likewise, just look at all these positions, you will find that at each position you have a mixture of single bond and double bond. I know this without seeing, because I am experienced, and by solving much problem you too can get this feeling and intuition. So at each position you will have a double bond character, right? Now this is about double bond character. Now you worry about the charge. Now you have to look at each position about the charge. Now look at this oxygen. This is neutral, positively charged, positively charged, positively charged, neutral. That means this oxygen is neither neutral nor positively charged. It will somewhere between 0 charge and +1 charge. That means some fraction of charge. That means del plus. Similarly, you will look at ortho and para position have negative charge. If you look at this ortho, it is neutral, negatively charged, neutral, neutral, negative, neutral. That means neither it is neutral nor it is negatively charged. That means neither it is having 0 charge nor -1 charge, somewhere in between 0 and -1. That means del negative. Similarly, para del negative, similarly other ortho del negative. So this is the resonance hybrid. Now the thing is, oxygen is pumped its electron into the benzene ring. For that reason, these 3 atoms on the benzene ring is having some amount of negative charge, which without the effect of resonance were not having that negative charge. So this OH group had an effect of pumping in the electron and making some sides of that benzene ring electron rich, right? 2 things has to be noticed. Whenever there is an electron rich atom directly bonded to benzene ring, always it will pump its electron into the benzene ring. Now instead of this OH, we could also have NS2. That means aniline. Instead of OH, we would have NS2. Instead of the NS2, we could have SH. Any other atom, any other heteroatom having lone pair will pump its electron into the benzene ring. That's one thing. But what is more important is, when they pump the electron, they pump to ortho and para position. They don't pump to meta position. Meta was neutral previously, and meta now is also neutral. But now ortho and para are electron rich. This is something very vital and very important, and this will be one of the things that will rule our further discussions ahead. So what you have to know is, when electrons are pumped, they are pumped to ortho and para position. Right? Now let's draw one more RS to better understand this topic. Suppose we have benzaldehyde. Benzaldehyde means aldehyde group on benzene. That is benzaldehyde. Now, to draw the resonating structure of benzaldehyde, let's start drawing resonating structure. Let's draw the electron rich site and electron deficient site. Now this oxygen will have del negative, this carbon will have del positive. Why? Because of electronegativity difference. Because of electronegativity difference, is the bond, the electronic density of this bond will shift towards oxygen, making this oxygen electron rich and this carbon electron deficient. That's why this oxygen is electron rich, this carbon is electron deficient. Now to start drawing the electronic resonating structure, what we will try to do is, we will try to bring our electron rich site adjacent to electron deficient site. The idea is, if we bring plus minus adjacent, those plus minus, this minus means 2 electron, this plus means no electron, empty orbital. So those 2 electron comes in between and forms a bond. So if you bring a plus minus adjacent to each other, that means it's a bond. Alright, so if I put the electron of this bond into oxygen, that will form O minus, and that will create C plus. And somehow if I bring negative charge on this carbon, then this C plus and this C minus will form a bond. So let's do it. How to bring this negative charge? The bond of this bond, the electron in this bond have to be put into the orbital of this carbon. So the arrow will start from the bond, end up to the atom, signifying that the electron of the bond is going into the orbital of this atom. So we will get our first RS. Oxygen will have negative charge because this bond has been shifted to oxygen. This carbon will have positive charge, right? And this carbon is having negative charge, so they have formed a bond. We will not show plus minus because plus minus can't exist like this. The electron from here will very fastly be gushing into the empty orbital, and immediately they will form a bond. So we don't show plus minus. For understanding, we just visualize that plus minus. If we now, electron has been shifted to this carbon, so this carbon is electron deficient, so this carbon will have a plus charge. Overall molecule will be neutral if it was neutral initially. Initially this benzaldehyde was neutral, finally it is also neutral, plus minus will cancel. Overall it is neutral. Charge neutrality will always be applying everywhere. So this is the first RS. Now what will we do? We will again draw the resonating structure. This plus will come, another resonating structure, this plus will come to para, and again another resonating structure, this plus will go to other ortho, and in the yet another resonating structure, again you will have a bond between carbon and oxygen, making it neutral but changing the position of pi bond in the ring. So I'm not doing it, hoping you will cope up with it, and I'm directly drawing the hybrid because we are grown up now, aren't we? We have been studying organics since long time. So if we have to draw the hybrid, then the thing is we have to draw all the single bond. Don't draw the double bond, don't draw the charge. Draw the basic structure with all the single bond. Now worry about the double bond. Now as you will see that at each position, in some RS you will have single bond, in some RS you will have double bond. That means at each position neither you have a single bond, neither you have a double bond. What you have is a double bond character. So at each position I am drawing dotted bond with dotted line. That means this is not a pure double bond, this is having some double bond character. This is a pure single bond because never we had a double bond here. Now worry about the charge. This oxygen is having negative charge, and in the ring we are having plus charge. In the ring we will have a plus charge. So what we see in here is this aldehyde group has pulled electron from the benzene ring, so benzene ring is developing plus charge polarity or positive charge on carbon atoms. That's one thing. So what you have to observe is, if you have a carbon, if you have any atom which is electron deficient, so here we had carbon and this carbon was electron deficient, and that atom is directly attached with benzene, then the electronic density of benzene will diffuse out into the orbital of that atom. So if you have a rich site adjacent to benzene ring, electron will come into the benzene ring. If you have a deficient site outside the benzene ring, then the density will go outside the benzene ring. So benzene ring is both electron donating and electron pulling, depending upon what is attached to the benzene ring. Right? So here we had electron deficient site. So benzene ring has diffused its electron into the empty orbital of this carbon, losing its own electron. Or the other way to look at it is the aldehyde group has pulled the electron from the benzene ring. So aldehyde group is electron withdrawing group, and it has withdrawn electron from ortho and para position. That means meta is again unaffected. When you pump electron, meta is unaffected. When you withdraw electron, meta is unaffected. When you pump electron, ortho and para become electron rich. When you withdraw electron, ortho and para become electron deficient. So whatever it has to deal with ortho and para. Meta is neutral to this effect of whatever the group is attached to the benzene ring. These two observations are very important to study this topic further. Alright, so bear this in mind. Whenever electron will be withdrawn, it will withdrawn from ortho para. Whenever electron will be pumped in, it will pumped into ortho and para. Meta will be quite indifferent to it. Alright, now let's go ahead. Now, suppose I have benzene ring and I add an electrophile to it. Now the question is, where electrophile will go and get attached? The answer is anywhere, because all the 6 carbons are identical. It doesn't matter where benzene ring is. So the chance of electrophile getting attached to any carbon is same. The probability will be 1/6 at each carbon. So you draw it like this or you draw it like this, it hardly matters. If you rotate the structure by 60 degrees, you will end up in this structure. So both are same because all the carbons are identical. So there's no issue of deciding the position of the incoming electrophile when you have all the positions identical. But suppose you already have electrophile E1 on benzene ring, and now again you are adding an electrophile E2 on benzene ring. And now again that question pops up, where it will go? Now there are three kinds of carbon atoms. 1 1, these two atoms are same with respect to electrophile. 2 2, these two are again are same. And 3, three different sites, and it can go to any three different sites, and they all not are equiprobable, they are not equilikely. So here then we have to reason, we have to study, we have to give logic, we have to give scientific basis where E2 will go. Now where E2 will go, E2 will go where the electronic density is highest. Based on the previous discussion, if E2 even is such kind of electrophile that it is pumping electron, then it will be increasing electronic density where? At orthopara. That means at 1 1 and 3, 1 1 and 3 are orthopara. Now if E1 happens to be such an electrophile that it is pulling the electron, then it will pull from where? Again from ortho and para. 1 1 and 3. That means if E1 happens to be electron rich, then 1 1 and 3 will be negatively charged, 2 will be neutral. Now understand this very well. If 1 1 3 are electron rich and 2 is neutral, then 1 1 3 are more electron rich than 2. Then E2 will go to 1. But if E1 is pulling the electron, then it will be pulling from 1 1 and 3. That means 1 1 and 3 will be having plus charge and 2 will be neutral. And of course neutral is more electron rich than positively charged electron deficient site. So in that case, if 1 1 and 3 are having plus charge, if they are having del plus and del plus, and 2 is neutral, then which is more electron rich, 2 or 1? 1 is having del plus charge, 2 is neutral, and of course 2 is more electron rich than this deficient site. Then E2 will go to 2. But suppose 1 1 and 3 are having negative charge, because this E1 might be pumping electron. Then what will happen? Which is electron rich? 1, 2 or 3? Then 1 and 3 are more electron rich than 2. So in that case, this electrophile will go to 1 and 3 and not 2. So this is how we will decide where the next incoming electron will go. So as if the electrophile which is already present on the benzene ring is directing the next incoming electrophile to go to ortho or go to meta or go to para. So this is called directing effect of the electrophile. So as if this E1 is directing E2 where to go. That's why this is directing effect. So this is depending upon the directing effect of E1, E2 will get attached to the carbon. So technically we coin a term here. E1 either will be ortho para directing. That means if it is electron pumping, then it will pump electron to ortho and para positions. So the incoming electrophile will go to ortho and para positions. So E1 will be called as ortho para directing. And if E1 is electron withdrawing, then E1 will be withdrawing electron from 1 and 3, that means from ortho and para. So E2 will go to meta. So as if E1 is meta directing. So the electrophile either will be ortho para directing or it will be meta directing. Right, so that is the directing effect of E1. Now next task will be looking at the electrophile. How would we identify whether it is ortho para directing or it is meta directing? Now I have given you the answer already. I'll discuss this briefly, but let's jot down what we have discussed up till now. Now we have discussed lots of things. The first thing is, if group the group attached to benzene, or to be specific, if the atom attached to benzene ring is electron rich, then the group will be activating group. Activating means you are boosting up the benzene ring for reaction. You are activating it for the reaction. You are making it more vibrant and active for the reaction. That means activating. Which reaction? Electrophilic reaction, because for electrophilic substitution you require more electronic density on benzene ring. So if you pump more electrons, so if you have any group as such, and the atom directly bonded with benzene ring is having a lone pair or a negative charge. That means it must be electron rich site. Then of course this group will act as a electron pumping group or electron donating group, or they call it most commonly as activating group. Activating means it is making benzene more active for the reaction by increasing its electronic density. So this is how you will identify. Suppose I am being given phenol OH on benzene ring. So whether OH group is electron withdrawing or electron donating, oxygen has lone pair. Oxygen has two pair of electron, and those electrons will go into resonance with benzene ring. So this is activating group. OH is activating group. Similarly, how would we identify about aniline? Aniline is activated ring or deactivated ring. Ring means this ring. The ring in aniline is activated or deactivated. Activated means electron has been pumped. Deactivated means it has been withdrawn. So as you can see, they will not draw this lone pair, but you know that nitrogen has one pair of electron when it is making 3 bonds. So this nitrogen has a lone pair, you know that, although it will not be drawn in exam, but you know it and you have to know it. So nitrogen is having a lone pair, so this lone pair will go into the benzene ring because nitrogen is electron rich. So aniline will be an activated group.